Hello guys, so welcome back to this virtual lab session. In this video I'm going to explain you how to generate a V curve and inverted V curve in a three-phase synchronous motor when it is loaded. Now drag this experiment to the workspace and you can see the respective circuit diagram of a three-phase synchronous motor. Here below you can see this is the synchronous motor and the outer one is the armature or the stator inside which the rotor is present. The synchronous motor is connected to a DC shunt generator through a shaft, and this DC generator is connected or disconnected to a electrical load. This synchronous motor is connected to two parts. The rotor is connected to the field current where the varying rheostat is placed, and the ammeter and the voltmeters are placed to measure the field current and field voltage. And the armature is connected to a the AC power supply. Initially the load is disconnected. So let us see how this process takes place under loaded condition. Below here this is the ratings of the DC shunt motor, shunt generator and the synchronous motor, and these are the abbreviations. Let us start our experiment. Initially all the switches are opened, so we are going to close this armature, the AC supply, and you can see the readings here. Initially by varying this we can see there is a change in the speed. You can see as I'm going varying, you can see the speed is changing in the speedometer. This is due to the rotor starts rotating with the armature rotating field. So we are going to set this to the rated voltage, that is you can see synchronous motor rating, the armature voltage is 415. So by varying this by increasing it, we are going to set it to 415 voltage. So now it is set and it is nearly to the synchronous speed. Now by closing this field current, we can vary the field current through rheostat. So now we are going to apply load. I'm going to give full load. Okay, now by changing this, by increasing the rheostat, the current starts increasing in the field current, because of which there will be a field in the rotor, and this is set to the synchronous speed. So initially we have set for 0.01 and we are going to store it and show it, and you can see here the readings are shown. Likewise we are going to do it for several readings like we did in the no load test. By increasing this field current, you can see the armature current and the power factors are increasing. You can see from top to bottom the power factor starts increasing. Even the armature current, the armature current is initially decreasing from top to bottom. So likewise we are going to vary for several readings. Start storing data and show data. I'm doing it for the full load test. You can even do it for the partially loaded. So I have taken reading for several datas until the rheostat, I mean the to the limit of the rheostat. So now we are going to generate graph for V curve and inverted V curve. For V curve, the graph is for the applied field current versus the armature current. So by selecting this, give the first one to generate graph between the field current and the armature current, and you can see this, it bends like an V. So this is mentioned as V curve. Now for inverted V curve, we are going to take the field current versus the power factor. You can see it looks like an inverted V curve. So here also you can see initially the power factor starts increasing. This is due to under damping, and this is the unit power factor is the critically damped, I mean the normal damping, below which the power factor starts decreasing. This is due to over damped. So I have explained both no load V curve, inverted V curve, and the loaded V curve and the inverted V curve. Thank you.